This is Mr. Martin. These are the video notes for section 9.5 for Geometry Honors. We're going to be talking about the distance formula today. Probably a formula that you've used in the past. We may look at it in a little bit different way today. So let's take a look at 2 points on the coordinate axis. Let's look at point A, and I'm going to give this coordinates x1 comma y1, and point B, and I'm going to give this coordinates x2 comma y2. And let's say we want to find the distance between these 2 points. So really the distance formula is just a form of the Pythagorean theorem. So what I'm going to do is I'm going to make a right triangle here, and then we'll figure out what the coordinates of this point C are. It's over to the right the same amount as point B, so its x coordinate is going to be the same, so that's going to be x2. And it's up the same amount as point A, so its y coordinate is going to be the same as A, so it's going to be y1. So now we have this right triangle, and if I wanted to find the length of AB, I could use the Pythagorean theorem. So I would have that AB squared is equal to AC squared plus BC squared, and AB squared would be, if I need the distance from A to C, so that's the difference in the x coordinates there, so that would be x2 minus x1, and the order I subtract these really isn't important since I'm squaring it, it's going to become positive anyway. And I need the distance BC, so that's the distance between y2 and y1, so that'll be y2 minus y1 squared. And then if I want to solve for AB, I just take the square root of both sides. So I end up with AB is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then you have your distance formula. So if you kind of think of it from where it comes from the Pythagorean theorem, hopefully it'll be easier for you to remember. Now, we're going to be doing some coordinate proofs, sometimes called analytic proofs. Coordinate, sometimes called analytic proofs. And before we get into exactly what they are, I'm going to give you a little tip, because we're going to be placing geometric figures on a coordinate axis. And what you're going to want to do is select a convenient place on the coordinate plane for your figure. And we'll take a look at a couple different examples. So, for example, let's say we were looking at a right triangle. Okay, if we wanted to place this on the coordinate plane, a convenient place would be to put the right angle at the origin. And then we would just put our triangle somewhere in here with our right angle at the origin. We would have some point over here. I'm going to call this point A, comma 0. Since I put the right angle at the origin, I know the y-coordinate of this point has to be 0, and it's going to have some x-coordinate A. And then this point up here, we didn't go left or right at all, so that would be a 0 for the x-coordinate. And I would go up another different distance. We could call that B. And of course, at the origin here, we would have 0, 0. So after you do a few of these problems, hopefully you'll get the idea and you'll get better at them. I think persistence is a key for these. Let's take a look at an isosceles triangle. So again, we want to try and find a convenient place. So let's put one of the vertices at the origin. And in this case, when we define our variables, so these are my legs, if I come out here I'm going to make this 2a comma 0. And the reason that I'm going to do that is because I know that my vertex here, its x-coordinate is going to be halfway to the x-coordinate of where this leg hits the x-axis. So if I make this 2a, then my x-coordinate over here is going to be half of that, which would just be a. And this way I avoid some fractions in my problem. And then my y-coordinate is just some arbitrary coordinate at this point, so we would just label that b. All right, so keep in mind you may want to double it so that when you label the other things, you don't end up with fractions. All right, let's take a look at one more. Let's take a look at a parallelogram. And again, we're going to put it right at the origin. And we're going to remember some properties of parallelograms. So I've got these 3 points here that I'm going to have to label. Again, we've got the origin there. So I'm going to let this point be a comma 0. And then I'm going to let this point here be b comma c. Now I know that these two sides are congruent, and I know that the length of this bottom segment is a. So if I'm up here at b comma c, in order to get over to this point on the end, I'm going to have to go a distance of a. So I know that my x-coordinate over here is going to be a plus b, right? Because I need to go a distance of a, but starting at b. So a plus b. And then I'm also up the same amount as this, so my coordinate there would be c. So again, make sure that you're practicing. Make sure you're doing those problems in the homework. And you shouldn't have any trouble. So let's take a look at a couple of examples before I end the video here. So let's say we are given that point A is 4 comma 3 and point B is negative 2, 8 and point C is negative 4, negative 5. So the first thing that I want to do is I want to find the slope of the altitude to BC. So if you remember, altitude forms a right angle, so I really don't need to know anything about the altitude, but if I can find the slope of BC, then the altitude slope is going to be the opposite reciprocal. So if I can find the slope of BC, I'm going to use a lowercase m for slope. Slope is y2 minus y1, so that's going to be, let's do 8 minus negative 5, and then negative 2 minus negative 4, so that's going to give me 13 halves. Okay, so that means that the slope of the altitude, will be the opposite reciprocal. So that means it's going to be negative 2/13. The opposite and also the reciprocal. Alright, so normally it's a good idea to just graph the 3 points just to take a look at, a basic idea of what these are going to look like. Let's add in a little more space here. So I'm going to make a quick sketch of these. Doesn't have to be totally accurate, just to give you a little idea. So A is 4, 3, so it's going to be somewhere out here. So there's A, 4, 3. And B is negative 2, 8. So maybe somewhere up here. Negative 2, 8. And C is negative 4, negative 5. So maybe somewhere over here. And these 3 points form a triangle. And really what we found now, we found the slope of the altitude to be c, so I found the slope of this dotted segment there. Alright, so for part B, I want to find the length of the median to side AB. So here's side AB over here. The median has to go right to the middle. I'll call that point E. So in order to find the length of that, I need to know what the coordinates of point E are. So step 1, I have to find midpoint of AB. So midpoint is like an average, so I know that that point is going to be -2 plus 4 divided by 2, and 8 plus 3 divided by 2. So that's going to give me 1/11/2. And step 2, once I have that coordinate, step 2, we're going to find the distance. So now I'm going to go from C to E, because that's the median. So that dotted segment there, I'm going to find the length of that. So the length of CE, that's going to be the square root. So I'm going to subtract the x values. So that's going to be 1 minus -4 squared. And I'm going to subtract the y values. Again, the order that we subtract these really isn't important because we're squaring them anyway. And we'll do this one as a decimal. Make sure you just follow the directions to know whether you want to do it as a decimal or as in radical form. And we should get about 11.6 units. Okay, so make sure that you're doing all the problems in the section, and ask me questions when you get to them, because there are some difficult problems in this section. And we'll see you next time.